Here's lesson 109, letter C. This one's really tedious. That's why I didn't give you very many of these ones. It wants us to compare, and it's funny because it says compare the graphs of 3 log functions. Well, there's only 2. So we're going to compare them. Now your book already did compare them, and your book said that the higher the base, the lower the graph is going to look. But really it's best for you guys to kind of look at these yourselves. So I hope that you know that the base of a natural log is e, and if you put e in your calculator, it's about 2.71-ish. And then the base of a common log is 10. So what I did is I grabbed the inverses of these, because those are exponentials and they're easier to deal with. So the inverse of this one, the 5 is just multiplying by it, but the inverse of this one would be e to the x, and the inverse of this one would be 10 to the x. Okay, but the 5s are, they have that 5, they both have a 5 in front of them, so it's multiplying like that. I made a table, and then I just used -1, 0, and 1. I think we kind of know how the shapes of things are, like they usually kind of go up like this, and so we'll just use those to kind of guide us, and hopefully we won't have to plot too many points on these. So the way I got my answers here is I know that anything to the -1 power is 1 over itself. So I got 1 over 2.7 times 5. Well, that I just stuck in my calculator 5 over 2.7, and I just rounded my decimal to right there. Okay, and then I plugged in 0. Well, 0, anything to the 0 power is 1, and 1 times 5 is 5. Anything to the 1 power is itself, so I'm kind of rounding here, but I got 2.7 times 5, and that's where I got that number from. I kind of did a similar thing here. 10 to the -1 would be 1 over 10. 1 over 10 times 5 would be 5 over 10, and 5 over 10 is a half, and 10 to the 0 power would be 1, and 1 times 5 is 5. And then 10 to the 1 power would be 10 times 5, that's 50. So now I remember that these, what I'm trying to graph are these ones up here. The reason I even did any of this is now I'm going to use the ordered pairs backwards. I'm going to use that as a x and that as a y when I'm graphing, so that I can get their inverses. Okay, I'm not even going to graph the, I'm going to, by graphing these backwards, I'll be graphing this function and this function backwards, in that I'm going to use the y first and the x second. So that's somewhere close to 2. It's 1.9. And that's -1. So, and I'm not super surprised that they ended up down here, because remember, here's the line y equals x, and so the exponentials would have been up here, and then these other ones are probably going to be down here like this somehow. So there's the first point, and the second point would be at 5, 0, because I'm doing the inverse. 5, 0, 1, 2, 5, 0. That's 5, 0, right? Okay. And then 13. Hey, 13.5, 1. Hey, how's this gonna work? 1, 2, 3, 4, 5. Well, that sure tells me something. So I already know, just from, because I've been graphing some of these all day, so I already know it's going to go kind of like this. Okay. Now, I don't really want to graph this point right here, because, I mean, 50, that's way, way, way out there. But I'm still going to use these numbers to kind of eyeball what's going to happen, so I can answer their question that they asked me. Okay, so I'm going to graph these backwards. It's going to be 1/2, -1. 1/2, -1. And then it's going to be 5, 0. So that, they share that point, right? And then, but this one, See how this one's going to make the graph, it's actually going to go lower because this one has to reach all the way out, and I don't want to go there, but it's going to go all the way out to 50. 50, way, way, way out there. So it's going to be at 50, 1. So see how that's going to kind of it's going to be underneath, basically. Once they hit this point right here where they cross, I don't know if you can see colors on the YouTube or not, but this blue graph is going to be lower. So this is the graph of 5 log x. And this other one, it's supposed to be in black. This is 5 ln x. I didn't give you a lot of these, and I guess you can probably see why. But we do want you to know that the bigger the base, the lower the graph if it's a logarithm. Okay, and so that's what they're wanting us to answer. They're saying compare the graphs of the logarithmic functions to see the effect. So you could just say the larger the base, the lower, we'll just call it lower, the lower the graph. Something like that. Your book said the larger the base, the lower the graph. Yep, that's what they said too. To the right, let's add this, to the right, because it's actually not low, it's only lower to the right of x equals 1, right? And that's it for lesson 109.